In our last video, we looked at how to horizontally and vertically shift a graph. In this video, we want to look at how to reflect a graph. So we want to look at reflection in the x-axis and reflection in the y-axis. Now, reflection in the x-axis would be like I painted this red L in wet paint, and then I folded my piece of paper on this x-axis. It would transfer that image down here. All right. So again, reflection in the x-axis is whatever you have up here. It's like you fold it on the x-axis and it would transfer down here. All right. Reflection in the y-axis, very similar. So again, we have wet paint over here where we draw our L. But this time we fold it on the y-axis, and so that image would transfer over here. So that would be a reflection in the y-axis. Now, how do we tell the equation that we want it to do that? Well, if you put a negative out in front of the entire function, that's reflection in the x-axis. If you put a negative just in front of x and plug it into the function, that's reflection in the y-axis. So let's actually start down here at the bottom and then we'll go back up to the top. Let's say that we've got the square root function. All right, that's one of our toolkit functions, so we should know what that graph looks like without needing to plot points. So here's the square root of x. All right, if we put a negative out in front of the entire thing, that's a reflection in the x-axis. So if I reflect it in the x-axis, where is that going to go? What's that going to look like? Well, it's going to come down and reflect across the x-axis into the fourth quadrant. So that's what my reflection in x would look like. All right, look at the next one. For the next one, we have a negative just in front of x plugged into the function. All right, so again, negative out in front of the whole thing is reflection in x. Negative just in front of x plugged into the function is going to be reflection in y. All right, so if this were wet paint and I folded my graph on this vertical axis, it would transfer over to the second quadrant. And so that would be my reflection. All right, so now they want to combine the idea from the last video, the horizontal and vertical shifts, with this idea of reflection. All right, so when you're doing this, you want to identify everything that's going on here. So what's the negative out in front of the entire function causing? Well, that's a reflection in the x-axis, right? And then what's this positive 2 going to cause? Well, any value subtracted from x is a horizontal shift. Can that 2 be moved to the other side? No, it's stuck to the x. So what's being subtracted from x is a negative 2, because this would be x minus a negative 2. Again, you can think of this as the opposite of positive 2 is negative 2. All right, so when we have multiple things to do, there's a particular order that we need to follow. We need to do our horizontal shift first, we need to do our reflection second, and we need to do our vertical shift third. And it will make it a lot less confusing for you if you put your vertical shift over on the left-hand side with your y and then do it third. All right, so we want to do our horizontal shift first. So that's a horizontal shift of negative 2. So I'm going to back up 2 and draw the exact same graph. Then I'm going to take that red graph and I'm going to reflect that in the x-axis. So when I reflect that in the x-axis, then this will be my final graph. This will be my final answer. All right, now let's go the opposite way. They're going to give us the graph, and we're going to come up with the equation. Okay, so here's our original function. Y is equal to x to the fourth. Looks a lot like x squared, just a little flatter at the bottom. So original function, y equals x to the fourth. So what's been changed about this one? Well, it was opening up and now it's opening down, so that means that it had to have been reflected, right? So it was reflected in what? In the x-axis. right? So then after it was opening up and now it's opening down, after it was opening down, what happened? Well, it vertically shifted down 1, so that would be a vertical shift of a -1. So to begin with, our original equation was y equals x to the 4th. So to tell it to reflect, remember we put the negative out in front of the entire function. So I have negative x to the 4th. All right, then for the vertical shift, remember we said it's better to group it with the y on the left-hand side. So any value subtracted from y is a vertical shift. So we would have -1 being subtracted from y. So y minus a -1 is y plus 1. So again, any value subtracted from y is a vertical shift. So we would have y minus the vertical shift of -1. Y minus a -1 is y plus 1. And then the negative out in front of the function tells us that it was reflected in the y-axis. Now remember that we said that the order that we do these steps matters. We said that we had to do our horizontal shift first, our reflection second, and our vertical shift third. Let me show you why that's important. All right, let's go back to that exact same problem that we just had, that y plus 1 is equal to -x to the 4th. If I had correctly identified that the negative out in front of the function causes a reflection in the x-axis, and I correctly identified that this was a vertical shift of -1, but I did not follow this order. Let's say I did my vertical shift first. Okay, so here's my original function, and then I would vertically shift that down 1, so that dotted graph right there is my shifted graph, and then I would reflect that in the x-axis. I would get this as my final answer. And if you put that equation into your graphing calculator and graph it, this is not what you get. You get this. So again, the order matters. All right, so let's look at this next one. So again, if we're comparing to the original function, you can see that this one was opening up and now it's opening down. So that would be reflected in the x-axis. And then after it was reflected, it also had a horizontal shift, and that horizontal shift went to the left 2 or back 2, so that would be a -2. So again, our beginning equation is y equals x to the 4th. So let's start with our horizontal shift of -2. Any value subtracted from x is a horizontal shift. So that's going to be x minus a -2 or x plus 2. And as we talked about before, you need to put that horizontal shift in parentheses with the exponent so that it attaches to the x, so it can't be moved to the other side with the y to be a vertical shift. All right, then the way we show reflection in the x-axis is we put a negative out in front of the entire function. So that would be our equation, y is equal to -x plus 2 to the 4th.